Hey friends, this is Tom Vaidyan. Welcome to part 2 of my automated testing for .NET Developers series. If you didn't catch part 1, you can check that out by clicking on the link in this video or in the description below. In that video, we defined what automated testing is. What are the different types of automated tests? We established why we want to do automated testing and the benefits that we can achieve by doing so. We also looked at tools that are available in this space. Specifically, we looked at xUnit, one of the most popular testing frameworks out there for .NET developers. We walked through how we can install it, and we wrote a few unit tests so that we can get a hang of the mechanics of unit testing. And in this video, we are going to build on that foundation and get a bit more immersed in unit testing. We'll go over what are some of the types of things that you can unit test in your code, and also go over some of the things that you do not want to test in your code. I'll also introduce you to the concept of mocking, and I'm using that term generically here. More on that later. Right now, we'll figure out how we can substitute parts of our code that we're not interested in testing, but still need to be set up properly so that we can test the things that we are really interested in. So let's jump right in. So here we are in Visual Studio once again. And in this section, we'll look at some of the common types of unit tests that we can write against our code. And for that, let's first look at the test that we wrote in part 1. Remember this first test that we wrote? We wrote a test against this sayHello method for our greeter class. The test that we wrote looked at the string that was returned by this method and checked to see if it matched our expectation. For example, if we passed in the value Tom, we expected the method to return a string that said hello Tom. So that's the first type of unit test that we can write. Tests that inspect the return value of a method. The sayHello method returns a string, and we invoked the code and checked what it returned to see if it met our expectations. What about the second test that we wrote? We wrote a test for our add-to-do method of our to-do list manager class. However, this method didn't return anything. So how do we go about testing it? We tested a public property that was available in this class, the property called to-do list. We inspected this list property after we invoked the add-to-do method to see if this list now contained the item that we added. This is the second classification of tests that we could write, ones that change the state of an object. When we first instantiated our to-do list manager class, the to-do list property had no items in it. And then we called the add-to-do method, which changed the state of the list from having no items to having one item. And then we checked the list to make sure that it was actually so. In fact, instead of simply assuming that the to-do list manager's to-do list property will have no items when we first instantiate the object, let's add a unit test to our library to make sure that the assumption will always hold true. So if a feature developer comes along and changes the to-do list manager class to maybe add a default item, perhaps, so our unit tests will trigger failures, and the developer will be made aware of the assumptions that we once made for this particular class and determine the right course of action. So let's go ahead and write that unit test. We'll start off with xUnit's fact attribute to denote that this is a test. We will write a method with the 3-part naming we've been using. The first part is, what are we testing? Well, in this case, it is the to-do list manager class itself. The second part is, what is the scenario? We're instantiating a new copy of this class. And the third part is, what is the expected outcome? We expect the to-do list to have no items at all. So now the first part of our AAA pattern, the arrange. We'll new up a copy of the to-do list manager class here. Next is the act part, but in this case we don't need to take any other actions. We're simply going to instantiate that class, so we can move directly onto the third part, which is assert. We want to assert that the to-do list has no items in it. We can do so by using the assert.empty helper method provided by xUnit. Now let's go ahead and run this test. And yes, it passes as we expected. Now, I want to update this to-do list manager class a bit, namely this add to-do method. Right now, there is nothing preventing a null or empty to-do item from being added into the to-do list. Let's rectify that. If anyone tries to add a new item that's a null value or an empty string or a blank space or a series of blank spaces, I want the add to-do method to throw an argument exception. So let's go ahead and add that. So we can use the string classes isNull or whitespace method to do this check. If the to-do item that is being passed in is a null value or whitespace, let's throw an argument exception error. And I'll have Visual Studio add in the appropriate using statement here. And I will also add a custom error message here. Now let's write some unit tests to ensure that this works as expected. We'll start off with a public void method. So what is it that we are testing? The add to do method. What is the scenario? When called with an invalid to do. And what's the expected outcome? We expect an error to be thrown. Okay, let's new up a copy of the to-do list manager class. Now let's call the add to do method with a null value. And when this is called, we expect an argument exception to be thrown. To check for that, we can use xUnit's assert.throws method. It takes a generic type parameter, so we'll specify the argument exception type here. And you will see here that this method is expecting an action delegate, so let's specify one here. And we'll pull in this add to do invocation into the body of this action. And last but not least, we'll decorate this method with xUnit's fact attribute. Now let's go ahead and run this test. Yes, it passes. So this is the next classification of tests that I want to bring your attention to, and that is to test for exceptions to be thrown. Now, we've only tested one of the scenarios in which this error will be thrown, and that is when a null value is being passed in. What about when an empty string is passed in, or some white space? Will the same error be thrown? Well, we can test that by making more tests. But better than that, this is a good candidate to try out the theory attribute and parameterized tests capabilities that xUnit provides that we looked at last week. So let's add the theory attribute. And then we'll need to set up some test data. We'll pass in a null value. And then we'll pass in an empty string. and then we'll pass in some white space as a third test. Now we need to modify this test method to accept that string as a parameter so that we could reference it in our tests. Now let's go ahead and run these. And yes, they all pass. Okay, before we move on, let's do some cleanup of our tests here in the To-Do List Manager test class. One thing you'll notice in these tests is that the first line of all my tests are the same. var sut equals new To-Do List Manager. Instead of repeating that in each test, what we can do instead is to define a constructor and do that initialization there. xUnit will run that piece of code for us before each test. Now let's take a look at these assertions that we are making in these tests. This first test, the assertion reads var result equals assert.single sut.todolist. What are we trying to say here? We are trying to say that this to-do list property of our SUT or system under test should have a count of one item. This next assertion here says assert.equal getMilk, result. What are we trying to say here? We are trying to assert that we expect the result to be getMilk. Instead, we have assert.equal getMilk, result. Take a look at the next assertion, assert.empty, sut.todolist. What's a natural way of saying that assert? We expect SUT or system under test to be empty. Let's take a look at this next one. What are we trying to say here? The action of calling addToDo should throw an argument exception. These assertions, although they work, would be better if they sounded a bit more like natural English. Well, there are libraries that we can pull in to help with this. I'm going to use a popular one called FluentAssertions. Let's install that using NuGet Package Manager. Now let's rewrite each one of these assertions using FluentAssertions. In this first test, instead of saying assert.single sut.todolist, let's instead rewrite that as sut.todolist, and then we'll use the should extension method that FluentAssertions provide. Then tack on the haveCount method and pass it a value of 1. In my opinion, although probably not perfect, this reads a lot better. Our to-do list should have count 1 or have one item in it. Next, let's rewrite this assert.equal getMilk, result. Wow, that sounds a lot better. Next, let's fix this assert.empty sut.todolist. Instead, we'll write it as sut.todolist should be empty. And let's rewrite this last test here. Instead of this assert.throws argument exception, let's write it system under test dot invoking, and this accepts a lambda x dot add to do item should throw argument exception. I'm barely scratching the surface of what FluentAssertions can do for you. Do check them out at FluentAssertions.com. The next type of unit test that we can write is the invocation of other methods from within the particular method that we are testing. Maybe the method that we are testing calls an external API. Maybe it makes a call to a database. Did those calls actually happen when we invoked our test method? We'll want to test and verify those. So in order to demonstrate that, we are back in our greeter class, which we have looked at previously. But as you'll see, I have made a few modifications here. First, I've introduced two interfaces, an iEmailer, which has a send welcome email method, and secondly, I've introduced an iDatabase repository interface that has a save name method. And below those interfaces, I have made concrete implementations of those. An emailer class that implements the iEmailer interface, and a database repository class that implements the iDatabase repository interface. As you can see here, this is just fake code that doesn't really send an email or save anything to a database. It is here simply for demonstration purposes. Now, back in the greeter class, I have set up two constructors. One that will take in an iEmailer and an iDatabase repository as parameters. In a real-world application, we will use a dependency injection system to instantiate those objects and pass those parameters in. But for this demo, I'll simply new up those myself in this second parameterless constructor here below. And back in our sayHello method, I've added a couple of lines of code. The first line calls the send welcome email method of my emailer class. The next line calls the save name method of my database repository class. Previously, we wrote a test against this method to see the method return the string that we expected to return. But we now have two new lines of code that are not covered by any tests. So let's go and write a couple of unit tests to ensure that these two invocations are actually being made. So we're back in the greeter tests class, and we'll start writing a new method. We're still testing the sayHello method. The scenario is still when called with name. But what are we going to assert in this test? It is that the send welcome email method of the emailer class is being invoked. So you may have heard in the past that we should use interfaces instead of directly referencing concrete class implementations to aid us in testing, and may have wondered what that meant. So here I'll demonstrate how writing interfaces helps us in unit testing. If you look back in the sayHello method and hover over the send welcome email method, Visual Studio tells us that we are calling the send welcome email method of the iEmailer interface. Yes, we are in the constructor using the concrete implementation of the emailer class, but as far as the sayHello method is concerned, it is calling the send welcome email method of the iEmailer interface. This is a very important distinction. What that means is that from the perspective of the sayHello method, it makes no difference that we're using the emailer class of today or a totally different implementation of tomorrow. From its perspective, it is executing the same exact code, which means that we can pass it a fake or mock implementation of that interface, one that we can have some insider information on, like whether a particular method on it gets invoked or not, for our unit testing purposes. And we don't have to manually craft that mock implementation for testing. We'll instead use a very capable and popular library, aptly named Moq, or MOQ, for helping us with it. So let's install that through NuGet Package Manager. Now that we have installed our Moq library, I'm going to add a using statement for Moq. Using Moq, we can create a stand-in or a substitute of our emailer class, like so. And we'll use the Moq class, which takes in a generic type, and we will pass it our interface name. And Moq will look at the shape of that interface and make a class with it and give it to us for our testing. We don't have to do any of that manually, which is awesome. Now let's set up a Moq database repository instance as well. Now we'll instantiate a copy of the greeter class, but I'm going to do so by using the overloaded constructor that takes in the emailer and database repository as parameters. And to it, I'm going to pass the mocks that we created in the lines above. Great, our arrange part is completed. Now the act. It is just like we've done before. We're going to call the sayHello method with the string value of Tom. And now for the assertion. What do we want to assert? We want to assert that the send welcome email method of an implementation of the iEmailer interface got called. We can do so by using the verify method provided by Moq. And it takes a lambda. Let's verify that the send welcome email got called with the value Tom, because that's exactly what we're specifying above. And in the second parameter, we can specify that we expect that send welcome email method to be called exactly once. Now let's go ahead and run this test. Yes, it has passed. And just as a sanity check, let's make an incorrect assertion. Let's assert that the send welcome email method got called with the input Jeff. Now, when we run the test fails, as it should, because the code is not doing what we are expecting it to do. So let's put it back and rerun. And once again, the test passes. So, as a recap, we've looked at the different types of things we want to test in our code. 1, we want to test outputs of methods or return values. 2, we want to test state changes in our objects. 3, we want to test the throwing of exceptions. And 4, we want to test the invocation of other methods from within the methods that we are testing. I also want to take a moment and list a few things that we don't want to test. We don't want to test the language or the framework that we're using. We don't want to test C# itself. The C# team will do that. We don't want to test the ASP.NET framework, at least not from the perspective of a unit test. We don't want to test external APIs, except for just to verify that we are invoking something. We might be tempted, especially once we start looking at code coverage numbers, to write silly, meaningless tests just to try and get 100% code coverage. But don't give in to that temptation. Instead, we will be pragmatic developers and write unit tests that will benefit us in the long run. Hey friends, my name is Tom Vaidyan, and I'm a software engineer with a focus on web technologies. Thanks for watching this part 2 of my automated testing series. I hope you found this useful. If you have questions or comments or specific things that you would like me to cover in future videos, please leave them in the comments section below. If you haven't already done so, please do hit that subscribe button and that bell notification icon so that you could be notified of future videos. If this helped you in the least, please give me a thumbs up so others can benefit from this material as well. If you didn't like it, please still leave me a like and a comment below on how I can improve. Until next time, happy coding and thank you.